Okay. Okay. Good day, everyone. Thank you very much for the introduction, Irina, and the background on the whole presentation. So I'm going to be giving the presentation or the update on Objective 1 wetland mapping. And as Irina said, it's a lot more than just wetland mapping. So I'm going to walk through that. So next slide, Diego. I'm representing a research team that includes myself, Irina, Ben DeVries, and Genevieve Ali, as well as a group of students and technical support staff. And we're working towards creating a wetland coverage database, including wetland gain and loss estimates over the past 30 years or so for all agricultural landscapes. Now, don't move it forward yet. There, now I've caught up with you. The tasks under Objective 1 as stated in the proposal are to compile existing wetland databases. This is in brief. If you could back it up one slide there, Diego. Develop estimates of landscape scale wetland coverage over a time series. Develop estimates of rates of loss and gain as affected by environmental change, and demonstrate and share the wetland data products. Next slide. Now, based on our experience, since the proposal was submitted, these tasks have evolved somewhat, and I suspect this is true for all the objectives. Specifically, in 1.2, the range of the time series extending back to 1970 and forward in time throughout the duration of the project. And under 1.3, explicitly addressing both climate variability and climate change, taking a bit of broader perspective on that, and applying a broader view on modifications to wetlands and their catchments, which I think was initially focused primarily on drainage, but now it's more on the management of the wetland catchments. I'm going to review some of the progress we've made towards the completion of these tasks. Next slide, Diego. The focus of our research is on two regions within Canada, the agricultural landscapes within the prairie region of Lake Winnipeg Basin and the agricultural landscapes within the Great Lakes Basin. And these areas contain about 90% of the wetlands on agricultural landscapes in Canada. Next slide. The national greenhouse gas inventories can only include wetlands that are considered to be under management. And so the question arises, are Canada's wetlands considered managed or unmanaged? Next slide. Governments have taken different approaches on this issue. In Canada, all wetlands are considered, which cover about 13% of Canada's land area, with up to 70% degraded or destroyed, are considered to be unmanaged. In contrast, most wetlands in the United States, with the exception of those wetlands at least 10 kilometers away from human activities, such as what you might find in Alaska, are considered to be managed. So there's a clear distinction there. And despite being considered managed, the United States has yet to include wetlands in their national greenhouse gas inventory reports. So a very different approach. Next slide. This question is one of many related questions that come to my mind anyway. Some of the other ones are wetlands water-covered land within an agricultural landscape, or are they water bodies separate from the agricultural landscape? Landowners can buy and sell wetlands associated with property, but are their rights for the use and management limited? Does the ownership come with management responsibilities? Who has political, legal, and administrative responsibilities over management? And it is an agricultural or environmental government agencies. And I know these go back to when I first started working with Ducks Unlimited on trying to capture wetlands within agricultural activities. And we met with Agriculture Canada and Environment Canada, and no one seemed to want to take political jurisdiction over the wetlands. They would all say it's the other person's responsibility. Now, from my perspective, we must consider both direct and indirect effects of management. I think this is what is really needed within the watershed and the airshed of a wetland. As such, they're either directly or indirectly managed, and they are a shared responsibility. So it's more of a holistic approach to this. Next slide, Diego. As Canada considers reclassifying from unmanaged to managed, the following factors need to be considered. First, there is a negative bias in the term managed. However, management can lead to either positive or negative outcomes in terms of organic carbon accumulation and greenhouse gas flux mitigation. And management could lead to positive outcomes if wetlands are protected, restored, or enhanced. For example, organic carbon stocks in restored wetlands may be greater than in intact wetlands. And intact wetlands being those that are not affected by management. Next slide, Diego. Two, human activity must be accounted for in the wetland itself, in the catchment contributing to the wetland. And three, the type, magnitude, and intensity of human activity must be considered. Number four, the managed state could be transient or permanent. For example, the organic carbon stock in a managed wetland can recover to the level of an unmanaged one, but according to the IPCC, once a wetland is managed, it stays wetland, presumably because the effects of management are presumed to persist indefinitely. A broader landscape view of wetlands and their catchments is required to understand, model, and manage organic carbon sequestration greenhouse gas emissions. And as Objective 1 tries to link with the activities, the tasks of the other objectives, I think this becomes quite important. The assessment and modeling of carbon and nitrogen must include inflows into a wetland from the surrounding catchment, the cycling within a catchment or within a wetland, and the outflows from a wetland down to downstream wetlands and beyond. Next slide, Diego. Okay, this leads to a fundamental technical issue for us in Objective 1 as we attempt to achieve our tasks. How do we define a wetland? What are the structural components and what are its metrics? A general definition is wetlands are areas of a landscape where water covers the soil for enough time to be strongly reflected in the vegetation and in the soil, and also the wildlife. In the prairies, we often refer to Stewart and Cantor classification system, which is largely based on vegetative communities, which reflect soil and hydrologic conditions. And again, to draw a contrast with the United States, in the USA, the presence of aquic soils is often used as the defining characteristics of wetlands and wetland conservation program. Next slide. As shown in this illustration from one of our studies in the prairies, the spatial structure needed to characterize wetlands and quantify processes affecting the sequestration of organic carbon and the mitigation of greenhouse gas emissions, as they are affected by management, is complex, but it is predictable. But is it necessary to have this degree of spatial specificity as shown here? And I'll just draw your attention to a few things. If you look at the wetland in the upper corner, you can see there's that catchment has upper, mid, and lower slope positions within the cultivated field around the wetland. And the riparian area in this particular illustration has two zones to it before you get to the inner wetland. And that's shown in the image to the bottom right as well, that spatial structure. And you can see in the piece of landscape under figure C there, the typical size and shape of these wetlands. They're very complex in shape, but they are very spatially coherent, and that they do generally have these types of spatial components to them. So let's look at some data from the study. I'm going to try to emphasize the importance of looking at the spatial structure. The data from along transects extending from wetland centers, so those arrows that shoot out from the center, those are what I'm referring to as transects, and they head from the wetland center out to the edge of the wetland catchment. And these are the sampling approaches that Pascal and Irene and I have used with students over the last number of years. Next slide, please. The riparian area, which I've highlighted here, at the slope bottoms are key accumulation sites for sediment, soil that moves in as sediment, soil organic carbon, soil particulate phosphorus, underscoring their role as natural filters or sinks that intercept sediment nutrients before they reach wetlands. And so you should get a sense from that. And if we go to the next slide, I'll zoom in a little bit more on there so you can see it quite clearly. You can see that the riparian area, that inner riparian area, is very, very significant in terms of what goes on within that wetland and the wetland catchment larger. It's a potential carbon pump. That's one of the questions we have at this stage. We're trying to understand the significance of that zone within the wetland catchment. It may be key to understanding how we can sequester carbon and the emissions of greenhouse gases within that wetland catchment. So whatever we do to manage that will be quite important for the overall picture of what goes on within wetlands in this study. Next slide, please. Clearly, it's critically important for us to capture the variability in stocks of organic carbon and associated nutrients that exist within wetlands and to identify hotspots for organic carbon sequestration and greenhouse gas emissions. And again, this is just the illustration from the previous slide. I've got some extra arrows added on here to emphasize a couple of points. It is important to understand the processes affecting these stocks to identify opportunities to manage organic carbon sequestration and greenhouse gas emissions within wetland catchments. So in the previous slide, I tried to emphasize that the riparian area is an area of significant accumulation of materials that are cycling and producing greenhouse gases and sequestering carbon. But they move from within the catchment. A lot of the material that enters the wetland is coming from the surrounding catchment, and there's multiple processes that are moving that material and therefore can be affected through management practices in and around the wetland. There's material that moves through the air, in other words, the air shed, moving into the wetland and through and over and out of the wetland. You have water that moves quite obviously towards the wetland center, and not forgetting that water actually exits the wetlands and connects that wetland to downstream wetlands and downstream waterways. And quite significantly, the green arrows are illustrating the movement of material simply by tillage from the cultivated field down towards the wetland. And this should emphasize the need to look at a catchment, a wetland, based on its catchment, all the processes that are operating within, because the lateral flows that are illustrated here tend to be quite significant, if not dominate, what we see in terms of the materials building up in the riparian areas. Now, we have nearly completed our study of the lateral transfers of sediment and associated organic carbon and nutrients between and within catchments. And these transfers by wind, water, and tillage erosion are small but significant, and they account for much of the material that accumulates in these riparian zones of agricultural landscapes. Next slide, please. So, back to this issue of managed and unmanaged wetlands. As Canada considers reclassifying wetlands from unmanaged to managed to make sure that they're captured in the IPCC efforts, the following data are needed. Our current work in the 2020s, obviously, and looking back to 2005, where Canada's Paris Agreement commitments were made, and 1990, going back to the reference year from the Kyoto Protocol used by Canada and other countries reporting on emissions, as well as going back to 1970, our residual year used to estimate residual emissions leading up to 1990. As well, we should look forward to construct scenarios to provide projections to 2030, obviously, and probably beyond to 2050. What we do will probably inform all of those projections into the future. Clearly, how we define wetlands has serious implications for data requirements to achieve these tasks. These are significant challenges as we move forward. Next slide, please. And there are other challenges we've identified as well. Automating updates of large area wetland inventories to reduce the costs of boots on the ground updates. That's a major challenge we have. And if we go to the next slide, see there's a list of technologies which help inform that. To that end, there are many satellites to map the different wetland components, but thinking back to the previous slides, to capture the desired spatial and temporal resolution will require considerable innovation. Next slide. And to illustrate such innovation, I've got a few examples of illustrations provided by the team. This one, using Landsat, we can map the probability of inundation. Next slide. In that effort, we generated the first version of these maps back in August 2023. And in May of 2024, we revised the inventories to mitigate overestimation of wetlands in years where flooding occurred. We tested different minimum frequencies of annual inundation, 1, 2, and up to 10 years, thresholds within a 10-year window using annual dynamic surface water maps with lakes, rivers removed in 30 areas of the Canadian Prairie Pothole region, where we had access to high-quality resolution wetland inventories provided from Ducks Unlimited Canada. We tested the minimum frequency thresholds using comparisons of calculated drainage rates and spatial accuracy statistics and visual assessments. Next slide. And this slide shows the results of an automated subpixel water fraction mapping method. We have a finished SWF, which that's the subpixel water fraction, time series product from 1984 to 2020 over the Lake Erie Basin, which was developed under an OMAFRA project in collaboration with Genevieve's team and Ben's team. Under the ECCC Great Lakes project, we are now scaling that up to the entire Great Lakes St. Lawrence Basin, while also updating the Lake Erie products to 2024. The slide demonstrates the use of the products for monitoring interannual trends and changes. Note that the Lake Erie Basin product is a quasi-monthly, meaning we can also observe interannual changes. Next slide, please. With the innovation mindset of continuously improving the wetland inventories, we are leveraging data from next generation sensors and applying statistical learning techniques to integrate multiple data sources, including optical and radar imagery, as well as novel geomorphometric indices derived from LiDAR. This data fusion enhances our ability to identify and classify wetlands, ultimately enabling more accurate assessments of carbon storage and greenhouse gas fluxes. And to elaborate on that a bit more on that point, existing inventories are mosaics of inventories from different jurisdictions of different times using different source data and different techniques and different spatial resolutions. And we need an approach that can provide wall-to-wall mapping of wetlands across time using standard data and methods. To that end, we identified and compiled existing published and unpublished data wetland inventories in the Prairies and Great Lakes St. Lawrence River Basin, including completing data sharing agreements and memorandums of understanding for obtaining proprietary inventories from conservation authorities or other government sources. And to the next slide. And a couple of examples of wetland data products, a couple more examples of wetland data products. This is showing the wetland recharge versus discharge status in the Beaver Hills Moraine area of Alberta, where we're using Landsat thermal bands to classify wetlands as groundwater recharge or discharge wetlands. Next slide. And from wetland area to wetland type, using statistical learning techniques to combine optical, radar, and LiDAR data to improve wetland carbon tracking. Further improvements to this are still needed. We need to incorporate ancillary data like the Agriculture and Agri-Food Canada's crop map to eliminate known errors, and use object-based classification to generalize noisy wetland features. Next slide. I think it's just a few more slides here. We were asked to discuss or to address these questions as we were all the objectives were asked to do these. So the first one, can we combine our wetland products to better estimate wetland carbon storage and greenhouse gas fluxes? And can we use our wetland products to generalize and scale Objective 2 measurements for all mineral wetlands on targeted agricultural landscapes? And I believe the answer to the first two questions is yes. I think we must. It does not necessarily mean we're going to be successful. We certainly need to attempt to do so. And obviously, we have to work closely with Objective 2 to make that happen. The third question, can we extend our wetland products to include mineral and peatland wetlands so that we can get wall-to-wall estimates of carbon storage and greenhouse gas fluxes in the Lake Winnipeg and Great Lakes watersheds? And I believe the answer to this third question is yes, but our estimates will be the best available. But the uncertainties associated with extending these findings from agricultural landscapes to non-agricultural landscapes must be may be unacceptably high without broadening the scope of our study. So I think that's an important note on that, that we do have a very well confined study to agricultural landscapes. And so taking it beyond that will probably mean we need a much broader scope of the study. The next slide. Looking forward, forward-looking requests and opportunities. Two questions there. what would we do if we had more resources, and what other grants are we applying for to pursue additional opportunities? And I've noted a few things, and Ben provided a few of these as well. First, characterize the structure of wetland catchments more completely in a broader range of settings, and this would focus on complex, highly variable structure of individual wetlands and the riparian areas. That's something that could be done. I still believe it could be done in the context of this study with existing resources, but it may require to extend beyond that. Extend the automated subpixel water fraction method that Ben had worked on to other optical imagery like Sentinel-2, which will allow mapping surface water dynamics at higher spatial resolution and temporal frequency than is currently possible with Landsat imagery. And incorporation of deep learning and AI modeling approaches to enhance wetland inventories. And note there, this is the topic of Michael Merchant's recently defended PhD at Guelph and partially funded through an NSERC DG. And the last point here, development of time series breakpoint detection methods for improved wetland change products. And Ben's team at Guelph has been working on this in Arctic regions with funding from the Polar Knowledge Canada, which is a project that's finished as of March 2025, so just recently. And he's interested in expanding this approach to other regions. And Ben will be submitting his next NSERC DG application October 25, and he will address this in some form. So there are some opportunities there. There's certainly a number of research needs that we could work through. And the final slide. Anticipated impacts. What knowledge process products can we take to influence the narrative about natural climate solutions and affect change? What continuous improvement measures are being offered, and what automated, repeatable, robust measurements are being offered? To that end, I think that stronger links to management practices and their impacts is one definite outcome from this work. And I think going back to that issue of catchments, which I work on, certainly by recognizing the catchments, the wetlands are integral to understanding what's going on within the wetlands, and focusing on the riparian areas, which is very strongly influenced by management, really makes us focus on not only what's going on within the wetland, but certainly around the wetland and its catchment. And those are the practices that are likely going to influence what goes on throughout the wetland catchment. In addition to that, data products that move beyond wetlands as static land cover types and allow for quantification of wetland functions and changes to those functions over time. We are developing, and again, I think this is Ben's group primarily, we are developing improved automated wetland mapping algorithms designed for consistent, repeatable application over large areas, basin scale with a view to national scale. So those are some of the impacts that we've identified from the work we've done so far. And that is my presentation on Objective 1. And I think there's a bunch of the people here on the line that are part of that objective. And so if you have any questions, because I think we have 15 minutes for questions, by all means, I think I can address parts of it, but Irina, Ben, and Genevieve may be able to address it as well.
Yes, and I'd also like to acknowledge the tremendous efforts of David Aldred and Michael Deloche, who are serving as GIS technicians for the network. A lot of this is made possible through their efforts as well.
Yes,
I'm going to moderate the questions answers, and I'm going to take, you finished early, David, so thank you for being on time and mindful of the time. One of the things that, as moderator, I can ask the first question, since there's no hands up yet, but I do encourage everybody to ask questions. One of the things about impact is trying to influence the narrative about inclusion of wetlands in the National Greenhouse Gas Inventory Report. And the reason why that you mentioned the work on managed versus unmanaged wetlands is because presently they are not included, although there is much work being done behind the scenes led by Doug McDonald on making sure that wetlands could be included down the road. Doug is going to be talking about that tomorrow. But my question to you, David, is do you think it's time that we could write an opinion piece or some kind of editorial to talk about this whole discussion about managed versus unmanaged wetlands and the considerations that you identified about the bias of management as being negative rather than also potentially being positive? And do you think that there is an audience that is interested in being able to read something about these considerations?
I would say definitely. It'd be very timely to start everyone thinking about what do we mean when we say managed versus unmanaged. I've always had the opinion that anything that sits within an agricultural landscape, sits within a farm, is definitely impacted to some degree by what occurs in the fields around, in this case, a wetland, but in the farm. So this idea of indirect management is important. And I think that what the Americans have done has just assumed that everything that sits in agricultural landscape is managed. And I'm not sure the history of why in Canada we have declared them as unmanaged. But I think for Canada in particular, since we're the ones considering changing our perspective of them from being unmanaged to managed, it would be very useful, very informative to try and get people to think about these things from a broader perspective, to make sure that we have the opportunity to manage these wetlands with respect to wildlife, greenhouse gases, you name it. There's a lot of reason for capturing them within the agricultural context. I think it does no one any good to say that they're unmanaged and set them aside. I don't think that makes any sense at all. So I would say that it is very timely to do so.
So I don't know if Sheil is listening, but I just want to hopefully he could show his face if he is listening. Hi, Sheil. I just want to share with everybody here that Sheil had invited Pascal, myself, and Doug McDonald to join a workshop in Washington that had a lot of discussion about this very topic, about managed versus unmanaged. And not to suggest that the United States is so far more advanced in terms of they have identified the wetlands as managed for their national greenhouse gas inventory reports, but they too have not formally included many of them because they're looking for ways of how to do that. I'd love for Sheil to be able to speak about that workshop and why we had it and what you think you can contribute to this narrative. But David, I think one of the biggest reasons is you just identified how hard it is. And so basically, if you have to look at all the direct and indirect processes, both within the catchment, the riparian, and the wetland, and I believe, Sheil, they refer to that as the land proxy approach is supposed to consider the wetland in the context of all of those other factors. It's really hard to be able to discriminate what is the function of the wetland itself versus all of those other interacting, interdependent processes. So maybe, Sheil, you could give us an update on what's happening in the US and any advice you may offer us in Canada on how we might move forward.
Yeah, so we had this workshop last summer when the EPA is trying to improve their inventory for wetlands. So wetlands are actually included in the US inventory, but one of the issues is even the inventory people didn't know how. The forest people were putting their own numbers on it. The ag people were putting their own numbers on wetlands. And then there was the flooded lands, which is managed waters. They were actually probably including wetlands in their, pond counts and everything. So kind of the first thing we did was get everyone on the same page on what they're doing. And we realized that there's just a lot of overlap. There's a lot of double counting going on. It's kind of a mess. And like you guys, the first way to solve that is to have one map that everybody uses. The forest people are using their own map, ag using their own map. So unless everybody's using the same map, it doesn't work. That was one of the main things we learned. Also, we learned that there's a lot of institutions, states, everybody wants to do a wetland inventory. And there was probably like 10 different just agencies and institutions all trying to do essentially the same thing. There's a lot of opportunity to harmonize and take advantage. There's clearly a lot of unknowns that people had in terms of like how to treat wetlands, in terms of global warming potential. There's acknowledgement that the 100-year warming is not great, but then the alternative was people jump to the 20-year warming, which is even worse, instead of like GWP star. So there's just clearly a lot of knowledge that was missing. I'm not going to give you guys advice on what to do because we're all still trying to figure it out together. But one thing I just wanted to make a comment on Dave's figures for the Prairie Pottle region. You got the zones going up into the upper slope, right? And then beyond that, you had ag fields. But in the Prairie Pottle region, realistically, when you get to the top of the hill slope, you're just going down into the next wetland catchment. It's kind of, right? The whole thing, the entire Prairie Pottle region could be kind of considered a big wetland catchment, just catchment to catchment to catchment. And I do wonder, like in this paper that you're talking about, Irina, if we modify Dave's figure so that essentially it shows that you're just going from wetland catchment to wetland catchment, and you could consider the entire region a wetland in some ways, that could be provocative, I guess. But some high impact in that respect.
Just on that point, Shield,
Yeah.
I've got just one comment on that, because I know when you look at the catchments in that illustration, we were looking at soil movement, and one of the controversies is there wind eroded material that's traveling across airsheds, which obviously traverse any kind of watershed boundary. And to be honest, we haven't been able to find any significant amounts. But that's why I did show that one set of diagrams with the airshed, and I referred to airshed. But this issue of the hydrology and hydrologic connection is important. And even Irene and I were talking about this a few days ago. And when we look at salt movement through these landscapes, you can consider those landscapes as watersheds, a cascade of wetlands, moving from small wetlands to larger and larger wetlands, similar to what you would have in a stream connectivity system. And we've shown that actually on one of our sites, that the salts accumulate down a chain of wetlands, very similar to what you would think of as a watershed. And so you could actually look at wetland landscapes as being a landscape that consists of a multitude of wetlands of different sizes, different shapes. That may be one way to look at these landscapes. So you still have to figure out how you're going to manage the wetland portions of it. So you're still going to be stuck with that. And there will be some need to delineate individual wetlands or components of wetlands to guide management and to quantify. So it's a perspective I would agree with, but we're still stuck with having to quantify the wetlands, the wetland components, to understand how to scale things up. Because even though it's a wetland landscape, the emissions are not uniform over the whole surface. Your sequestration of carbon is not uniform. So at some level, you're still going to have to provide that additional detail when it gets down to doing the modeling.
So David, I'm for some reason I'm really excited about this notion of being able to write a perspective on unmanaged versus managed, and the challenge in particular of going from individual wetlands to wetlandscapes, which is basically what both Sheila and David have just referred to. And I do admit I was fascinated with conversation I had in preparation with David for this today, him reminding me about the wetlandscapes, the interconnectivity of surface and subsurface flows that influence salinity, because that has emerged repeatedly in many of the objectives as a really important predictor of methane. And so I think that I'm going to tap that as an idea that we can maybe pursue on tomorrow afternoon when we start looking at some of these action-oriented opportunities that break out from individual objectives and work together. So I would say if anyone shares my enthusiasm for what Sheil and David and just talked about, please send me it in the chat, and I'll definitely follow up further with you. But we still have a question from Roland and another one from Sheer in the chat. So Roland, why don't you go first?
More of a comment and basically just using the chance for shameless self-promotion. It's of course, and I appreciate the complexity of trying to understand the natural system, but I wanted to add complexity to this because the natural systems of the Canadian landscapes are often managed by a decision maker, which is the farmer. And in order to utilize wetlands as a natural climate solution, we need to enable the farmer to figure out what management decisions can I make to basically successfully establish this natural climate solution. And so this goes both with basically then the information stream to let them know what type of wetland do you have, but also B, what management practice options do you have for your specific wetlands to maximize this natural climate solution benefit that you may be getting. And here we're not looking just at the what is status, which is complex enough and complicated enough, but basically then trying to provide the farmer with a decision-making catalog to say, you can implement X. And this is not only having an effect on your local wetland, but it also has a trickle-down effect in this system approach of like the landscape wetland complexity.
Thanks, Roland. I'll just make a quick comment. I specifically added that string of questions at the start to try and get people to recognize the wetlands. They're not just a physical entity in the landscape. They're controlled, managed by individual landowners, the property owner, as I referred to them, and as well as government agencies. But I think that the link to the landowner is key. If the objective is to change how we manage the landscape, you have to figure out who's managing the land. In almost every case, it's almost exclusively by the landowner, with very little government influence to date. And so somehow you have to make the connection. You have to make it clear to them what the wetland is, its value, and the impacts of the management. And yeah, we haven't gotten nearly far enough along that pathway, but you're right. And I think there's other people, I see Sheer bobbing her head up and down. Yeah, I think that is certainly an element that we have to spend more time focusing on, not just quantifying what a wetland is, but trying to understand how we manage it, because we will never affect greenhouse gases and carbon sequestration if we can't figure out what the management influences are and how to control management or how to affect management.
The good news is, however, if I may quickly, I was at a workshop once where we talked about like tools for farmers and information, and one of the farmers said, like, you know, if you come up with a new weather app, I already have 3 weather apps on my phone. I'm not interested. But if your tool gives me ideas about things that I do not know yet, then yes, I'm always open to learn. So, and I think this is a hook that we can kind of hook into, because if you position the farm in the context of landscape, which is something that the farmer themselves cannot observe, then this is additional information that most farmers will be inclined to say, like, yes, I'm interested to hear about this.
Thank you both for that interesting exchange. I now want to turn to Sheer's question in the chat. And I think this gets back to more of the technical, a technical question. And so David, but also Ben, David Aldred, and anybody else who might want to answer it. The question is, with existing data sets, let me just say, Sheer is wondering if there is any part of this objective with existing data sets for measuring wetland depth. Or do you know of any other database that might provide wetland depth? If so, would students working on the field measurements be able to access such a data set or the tools to measure this?
I know from our work surveying wetlands that we have measured depth, but that's just a one-off study, like a project. I'm not sure if it's a standard protocol for characterizing the wetlands. I know in terms of using remote techniques, LiDAR and any other remote technique only looks at the surface. You can infer the depth by looking at the shape and looking at the water level change and see how the water level change occurs. And you can infer the steepness of the slope of the wetland, therefore the depth. You could argue that the color of the water, at certain times, you can infer depth. So there are things, and the vegetation will also reflect the depth of the water too. There are ways to infer the depth, but in terms of direct measurement, I'm not aware of too many studies. Now, there are other people on the call that might. I know Genevieve has looked at wetlands, and I know Pascal's looked at more wetlands than most of us combined. I'm not sure if depth is considered a parameter. The one thing we've run into when we look at depth is depth of which part of the wetland. So I alluded to that in some of my comments. I don't know if I made them in the presentation, but when you're looking at wetland, the complexity of the wetland components, you can have a wetland that has 3 basins in it. And so it becomes an issue when we go to try and sample them, is to understand the spatial structure of the wetland, the bathymetry. And I'm not sure how many people have done that, but Pascal, you might be the best one to give some insight into that question.
Yeah, and I know some of the LiDAR projects that have been generated do predict essentially wetland volume, and from that you can back out what the mean depth is from those systems. Again, it's modeled based on topography of the landscape. I'm not too sure how great the accuracy is, but there are products there that we could definitely investigate. I do think it's an important question, because as we roll through some of the Objective 2 material, one of the questions I have is that I'm starting to think that wetland depth is going to become quite important for understanding methane emissions from these systems and how they behave seasonally.
So thank you. On that note, Pascal, I'm going to thank David Lobb for an excellent presentation. I would invite anybody else who would like to offer a response to share to do that in the chat. And I would like Pascal to now transition to Objective 2, which is looking at measurement of greenhouse gas fluxes.